Hello everyone. In earlier lectures, we have performed different experiments on virtual lab. Now today we will discuss and perform experiment 1, which is to verify the truth table of basic logic gates on hardware. So logic gates are basically the elementary building block of a digital circuit. There are three basic gates: AND, OR, NOT, two derived gates XOR and XNOR, and two universal gates NAND and NOR. These are called universal gates because you can implement any circuit or gate using these gates. Now there are different ICs for different gates. IC 7408 for AND gate, 7432 for OR gate, 7404 for NOT gate, 7400 for NAND gate, 7402 for NOR gate, and 7486 for XOR gate. To verify the truth table, we need these components, different ICs for different gates, then breadboard where we will implement the circuit, power supply, connecting wires, and LED to show the status of output. Now to verify the truth table, we have to follow the procedure. First, we will keep the trainer kit off while we are making the circuit on breadboard. We will connect plus 5 volt and ground leads of the power supply to the power and ground bus strips on the breadboard. The upper horizontal lines and lower horizontal lines. Upper ones you can make plus 5 by connecting plus 5 there, and lower ones you can make ground by connecting ground strips to the lower horizontal lines. Now you have to put your chips on the breadboard. So what you have to do, you have to look for the notch. So you point all the chips in the same direction with pin 1 at the lower left corner. The pin at the lower left corner, when you will see the notch, so the pin at the lower left corner will be your pin 1. So this pin 1 is often identified by a dot or notch next to it on the chip package. Now you have to connect plus 5 volt to all the 14th pin and ground to 7th pin. Now for making the connection, you select a connection and place a piece of hook wire between corresponding pins of the chips on the breadboard. After making, you have to make all the connections properly to avoid any error. Then you will turn on the power only when you completed all the connections. Now finally, you can give different combinations for the input and get the output, and you can verify the truth table accordingly. Now let's see how to implement it on hardware. So you can see we have to implement different, we have to verify the truth table of various basic logic gates on hardware. So for that we require these ICs, power wire and other connecting wires and breadboard. These are the IC diagrams for different gates, and, or, not, XOR, and so on. The 7400 is for NAND, 7486 for XOR, 7402 for NOR, 7432 for OR, 7408 for AND, 7404 for NOT. So these are the different ICs. You can see notch here. So this is the circuit. You can see this is the breadboard. This is the kit actually, and you have to make the circuit on this breadboard. These are horizontal pins which are horizontal holes which are shorted, vertical holes are shorted. This gap, these show insulation. Here is the power supply. Now this is 8-bit data switches which you can use to give the input. When you will make the switch on, it will give logic high, and when you will make it off, then it will give logic 0. So these 8-bit data switches you can use as input. These are input switches. Now these are this is 8-bit LED display. You can use this to show the status of output. If any of this LED glow, that means it shows logic high. Otherwise, if it is off, that means logic output is logic 0. There are different, you can see different things on this kit. This is the power supply. This is the power supply for the kit. You have to make it on only when you have connected you, you have done all the connections, you have made the whole circuit. So now we will place this. So you can see this is or get this IC. You will place this IC. These are the connecting wires. These wires are used to give the input or power supply. So you can connect the power supply and ground to horizontal, these horizontal holes. You see the notch in this IC, and you will place it here where there is a gap. That means these vertical lines are not shorted when here is a gap. So you have to place IC like this only. Now you are giving plus 5 volt to 17 to 14th pin, and you are giving ground to 7th pin. Now you are giving input to pin 1, and you are giving input to pin 2. So these vertical lines are shorted. That means this pin is at this is for input 1 and this is for input 2. And for output you are giving here at the LED display. Third pin you are giving at the output. So you have given the inputs from here. So this IC was for NAND gate. NAND gate 7400. So we will verify its truthable. We will switch on the power supply. So now we have switched on the power supply. So we will verify the truthable for NAND gate. So NAND gate 00 will give 1. So both inputs are 0. So output is 1. For 00, output is 1. Now we will make the connection 01. For 01 also output is 1. For 10 also output is 1. And for both 1, both 0 output is 0. So NAND gate gives logic low only when both the inputs are logic high. So this is 7402. So 7402 is for NOR. So we will verify its truth table. This is the truth table. You can see it will give logic high only when both the inputs are at logic 0. So similarly you have to place your IC at this gap, because these vertical lines and these vertical lines are not shorted. You will give the power supply to 14th pin plus 5 and ground to 7th pin. Now you can see for NOR gate you have to give input to 2 and 3 pin, and you will get output at first pin. You have to keep this in mind through IC diagram, that you will give input to 2 and 3 pin and you will get output at first pin. See here, 2 and 3 you are giving input and you are getting output at first. 14th pin you are connecting to plus VCC, and 7th pin you are connecting to ground. So for NOR gate both are right now, both are at 0. So for both 0 it is giving high, because NOR gate gives high only when both the inputs are at 0. So when you are giving you are giving 10 or 01, it will not do. When you are giving input 1001, the LED will not glow. So now coming to NOT gate, you can see when you give input 0, output will be 1. When you will give input 1, output will be 0. NOT gate IC is 7404. This is 7404. You can see notch here. So this notch, so this is pin 1 till 7 and then 8 to 14. So 7th pin you have to make it ground, 14th pin you have to make plus 5. At 1 you will give input and at 2 you will get output. And you will place your IC here so that these pins and these pins are not shorted. So you are giving plus 5 volt to 14th pin and ground to 7th pin. Now you will give input at first, input through this switch to first pin, and you will get output from second pin. So you are connecting second pin to this LED display. Now we will verify its truth table. As you have connected all. Now as you have given this logic high, so LED is not glowing. So for 0 input, for you can see for 0 it's glowing. For 1, if you are giving 1 output, it does not glow. This is for 0 input and this is for 1 input. So we have verified truth table for NOT gate. So now coming to AND gate, similarly we have to follow the same process. For OR gate also we have to follow the same process. 1 to input, 3 output. 14th and 7th pin are, 14th pin is connected to plus 5 volt for all gates and 7th pin to ground. So now we can verify the other basic gates in the same way. This way you can verify different gates in the similar fashion. So this way you can verify the truth table of all basic gates on hardware.